Hello, today we will start with stack applications. So, major stack application includes converting expressions from one format into other, like infix, prefix, and postfix notations can be converted from one representation into other representation. And the second one is evaluation of arithmetic expressions. So, let us start with what are these different formats of arithmetic expression. So an expression is defined as a number of operands or data items combined using several operators. So there are basically three types of notations for an expression. We can use infix notation, prefix notation, or postfix notation. So infix notation is the most common notation in which the operator is written or placed in between the two operands. For example, the expression to add two numbers, say A and B, is written in infix notation as A plus B. So in this particular example, the operator is placed in between the operands A and B. The reason is why this notation is called as a infix. Now in case of prefix, it is also called as a Polish notation. It is named after the honor of a mathematician, Jan Lukasiewicz. It refers to the notation in which the operator is placed before the operand as plus AB. So plus is the operator which is placed before A and B, these operands. Pre means before, right? And the last one is postfix notation. So in the postfix notation, the operators are written after the operands. So it is called the postfix notation. Postfix means after, right? Post means after. So it is also known as the suffix notation or the reverse Polish notation. So the above postfix is written in postfix notation. It looks like AB plus. Now the operator precedence. For simplicity, we will assume a simple set of operators like the parenthesis is there, exponent operator is there, multiplication division is there, and addition and subtraction is there. Okay, and only these operators we will assume in our expression for the sake of simplicity and understanding. Now the precedence, the highest precedence is to the parenthesis, then exponent is at the highest precedence next to that, then multiplication and division and addition and subtraction are at the lower precedence. Okay. So operator precedence, the first preference is given to the parenthesis and likewise as I told you. Now in case multiple exponent operators are there, right? Suppose exponent is at the highest precedence after the parenthesis and there are multiple exponent operators in an expression, then the operation will be applied from right to left. For example, suppose we have 2 raised to 2 raised to 3, right? There are multiple exponent operators. So what to do first? 2 raised to 2 and then 2 raised to 3 or 2 raised to 3 and then 2 raised to 2, right? Likewise. So in such cases, we have to apply the operation from right to left. So initially you have to do 2 raised to 3. It will come out to 8 and then 2 raised to 8. It comes out to be 256. Okay. Now operator precedence. After exponent, we have multiplication division operators to be evaluated. If both the operators are present in the expression, then operation will be applied from left to right. Okay. So the next preference is given to addition and subtraction. Again, if both addition and subtraction are present in the expression, then operation will be applied from left to right. So the operators that have the same precedence, they are termed as operator associativity. If we go from left to right, then it is known as left associative. And if we go from right to left, then it is known as right associative. So as you can see, exponent is right associative operator. Means when there are more than one exponent, we are applying our operations from right to left. And multiplication, division, addition, subtraction, all are left associative. Means what? When we are having multiple addition, subtraction operators or multiplication, division operators in an expression, we apply our operations from left to right. Okay. So associative order. As I told you, again exponent is at highest associative and it is a right associative, means we apply the operations from right to left, and for rest multiplication division lower than exponent and plus minus again in the lower level of associative, and they are left associative operators. Now let us talk about the first application of stack, that is conversion from infix to postfix. See, here we are going to talk about infix to postfix, but as you can see there are three types of notation. Total 6 conversions are possible: infix to postfix, infix to prefix, postfix to infix, postfix to prefix, and prefix to postfix, and prefix to infix, right? All 6 types of conversions are possible. We will discuss one or two in the sessions. So first, let us first discuss conversion of infix expression to the postfix expression. That means you are given a plus b and you have to convert it to ab plus using stack. So we are going to use stack data structure for this conversion. Whenever the operator will encounter, we will push the operator into the stack, right? Whenever your exponent, plus, minus, addition, division, parenthesis, these operators will encounter, we are going to push them onto the stack. And if we encounter an operand, then we append the operand to the expression. These are the two simple rules. Okay, very first level rules. Now in detail, the set of rules. Print the operand as they arrive. So whenever operand will come, we have to print them in a postfix expression directly. If the stack is empty or contains a left parenthesis on the top, push the incoming operator onto the stack. Means what? Your stack will be empty when you are before the starting of the conversion, right? So very first parameter will be there, okay, that you want to push. So when the stack is empty and incoming operator is there, so you have to push it onto the stack. Even if the stack contains the left parenthesis and operator is coming, so you have to push it onto the stack. If the incoming symbol is round bracket parenthesis, push it onto the stack, okay, directly. If the incoming symbol is closing bracket, closing parenthesis, then what you have to do? Pop the stack and print the operators until the left parenthesis is found. So when your incoming incoming symbol is closing bracket, then you have to pop the stack top until you find matching opening parenthesis. Okay. If the incoming symbol has higher precedence, then pop the stack of the then pop the stack. Okay. If the incoming symbol has the higher precedence than the top of the stack, okay, then you have to push it onto the stack. Okay, so stack में पहले से ही lower precedence वाला symbol है and जो आ रहा है वो higher है, तो lower precedence symbol can allow higher precedence symbol to sit on the top of it. This you have to keep in mind. So push it onto the stack. However, if incoming symbol has a lower precedence than the top of the stack, okay, इसका मतलब क्या है कि if your stack top is containing a symbol which is having lower precedence, which is having higher precedence, and incoming symbol is of lower precedence, so higher precedence symbol will not allow some lower precedence symbol to sit on the top of it, right? So what you have to do in that case? You have to pop the higher precedence symbol, okay, from the stack and then print it into the expression, and then test again the incoming operator against the new top of the stack. फिर से वही है situation, again you have to pop, then again you have to check, and then if the top is of lower precedence and incoming is higher, then only you have to push. If the incoming operator has the same precedence now, okay, that means we have the plus operator on the top of the stack and incoming operator is also plus or incoming operator is minus, both are at the same precedence level, okay, then use the associative rule. So incoming is plus on the top is plus, both are of same precedence, then you have to check whether they are left associative or right associative. Okay, in case it is left associative, you have to pop them and you have to print them, okay, the top of the stack, and then you have to push the incoming operator. However, if the associative is from right to left, then directly you have to push the incoming operator. So at the end of the expression, pop and print all the operators of the stack. Okay, so these are some rules how we are going to convert infix to the postfix. I guess it will be clear to you when we will see the example. So let us take an infix expression, k plus l minus m plus n plus round bracket o raised to p round bracket close into w by u by v into t plus q. Okay, we will create this table. First column is our input expression symbol, second column represents the stack, and third column represents the postfix expression. So let us scan our infix expression from left to right, one by one symbol at a time. So let us take k. Now k is my operand, right? My stack is empty, okay, and my k is operand, so I have to directly print the k in a postfix expression. Then second symbol is plus, so plus is my operator. Okay, now you have to push the operator into the stack. Stack is empty, I can directly push my plus operator onto the stack, so I'll push plus onto the stack. The next symbol coming is l. L is a operand. Okay, operand you have to directly print in the postfix expression, so I'll directly print l into the postfix. Then comes out to be minus. Minus is my operator. Okay, I have to push the minus into the stack, but already stack has plus operator. Okay, now check out. Plus is on the stack, minus is the incoming operator, both are having the same precedence level. So what you need to do, you have to check the associativity. So plus and minus are at the same precedence and they are left associative. So what you have to do, pop the stack of the pop the operator from the stack. So plus क्या था, उसको pop करना है. So plus को pop किया and put it into the expression. So plus बाहर आया and I have put it into the postfix expression. Now the stack is empty, so you have to push your minus onto the stack. Okay, then comes out to be m. M is a operand and directly you have to put it onto the postfix expression. Then comes out to be star, multiplication. Now check out. Minus is already on the stack and incoming is multiplication. Minus is low precedence and multiplication is higher precedence. So minus can allow multiplication symbol to sit on the top of it. So we have to directly push multiplication on the stack. Then comes n, directly put n into the expression postfix. Okay, after m. Then comes plus. Now check out. Plus is the incoming operator. What is the top of the stack? Multiplication. Now multiplication is higher precedence and plus is of lower precedence. So multiplication will not allow plus symbol to come and sit on the top of the stack above it. So what you have to do? You have to first pop the star or multiplication and put it onto the expression. Okay. So we have put it onto the expression multiplication. Okay. Then remains minus. Now minus is there and plus is coming. Though both are same precedence and left associative, then also you have to pop the minus from the stack and put it on the postfix expression. So minus operator is put on the postfix. Now the stack is empty. Now you can push plus onto the stack. Next is a opening bracket. Okay, so plus is there and opening bracket is of higher precedence, you can directly push. Then comes O. O is a operand, directly put it into the postfix. Then comes exponent. Exponent is of higher precedence, right? So than plus. See, while you are pushing, parenthesis is not an operator, right? It is just a symbol. So exponent is higher precedence than plus, so you can directly push it onto the stack. Then comes out to be P. P is operand directly in the postfix. Then comes out to be closing bracket. Now when closing bracket encounters, what you have to do? You have to pop all the operators until you find the matching opening bracket. So there is only one operator right now, that is exponent. So you have to pop exponent and put it into the postfix. And you have to pop the opening bracket also. Now the stack is containing only plus. Now the next one is multiplication. Now plus is already there in the stack and multiplication is incoming. Higher precedence, directly push. Then comes out to be W. It is operand. Put it onto the postfix expression. Then comes out to be division. Okay. Stack is containing plus and star and then division is coming. Now division is having the same precedence as that of a star. So you have to check its associativity. So it is left associative. So you have to pop the multiplication and add it to the expression, and then you have to again check plus. Plus is lower, division is higher, so push it. Okay. Then comes out to be U. U you have to directly put into the expression. Then comes out to be division. So again the same thing. Division is having the same precedence. So you have to pop the first division operator and put it after the U in the postfix expression, and then check it against plus. Plus is lower, division is higher, so push it onto the stack. Then comes out to be V. Add V directly to the expression. Then comes out to be star. Now the stack already contains plus and division. Your incoming is star, same precedence. So pop the star and put it onto the pop the division and put it after the V, and then push the star onto the stack. Then comes out to be T. Add the T directly to the expression. Then comes out to be plus. Now star is already there. Plus is coming. Plus is lower precedence. So you have to pop the star from the stack and put it into the expression. Then you have only plus. Okay. Then check again for plus. Now plus is again having the same precedence. So pop this initial plus from the stack and put it after the multiplication, and then push the incoming plus to the stack. Okay, so it will contain only one plus now. Then comes out to be Q. Directly you have to put the Q into the postfix, and lastly the expression is ended. So stack contains the plus, so pop the last operator and put it after the Q. Now check it out. KL plus Mn multiplication minus then OP raised to W into U by V by T into plus Q plus. This is your postfix expression for the infix expression represented by K plus L minus M into N plus O raised to P into W by U by V into T plus Q.